You live on a planet, a small blue world orbiting an ordinary star. But how small is small? How ordinary is ordinary? What lies beyond your sky? Beyond your solar system? Beyond your galaxy? Beyond everything you can see? Today, we're taking a journey. We're going to travel from where you stand right now all the way to the edge of the observable universe. We're going to see wonders. We're going to see catastrophes. We're going to understand just how vast, how incomprehensibly enormous our universe truly is. Strap in. The journey begins now. Let's start close to home. You're standing on Earth, diameter 12,742 kilometers, 8 billion people. Our entire recorded history, every war, every discovery, every person who ever lived, all happened on this rock. Above you is our moon, 384,000 kilometers away. It takes 3 days to get there. When astronauts landed in 1969, they looked back at Earth. Most described the same feeling, awe, fragility. Everything they loved was hanging in the darkness. But our moon is close. Too close to show you what I mean, so we keep going. Our solar system, Sun at the center, 8 planets orbiting: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, plus 200 moons, countless asteroids, comets, enough raw material to build 1,000 Earths. But here's the perspective that breaks your brain. The Sun contains 99.86% of all the mass in our entire solar system. Jupiter is so massive it could fit 1,300 Earths inside it. Saturn has rings made of ice and rock spanning 282,000 kilometers. Neptune has winds faster than any hurricane ever recorded on Earth, 2,000 kilometers per hour. And yet, the Sun is just a star, an average star. Billions of them exist. Let's keep going. We zoom outward, Earth becomes a dot. The solar system becomes a pale speck, and we enter. The Milky Way, our home galaxy, 100 to 200 billion stars. Some estimates say 2 trillion, arranged in a spiral disk 100,000 light-years across. 1 light-year, the distance light travels in 1 year, nearly 10 trillion kilometers, and our galaxy is 100,000 light-years wide. At the center sits a supermassive black hole, Sagittarius, a star, 4.3 million times more massive than our Sun. Not a hole you fall into accidentally. An abyss so powerful it tears stars apart, stretches them like spaghetti. We call it spaghettification. The tidal forces rip you to pieces long before you reach the event horizon. Around this black hole, stars orbit at insane velocities. We've watched one star, S0-2, complete an entire orbit in 16 years. It reached speeds of 5,000 kilometers per second, near the speed of light itself. But Sagittarius, a star, is just one black hole. Our galaxy contains 100 million of them. Black holes everywhere. Some small, some stellar mass, some feeding, some dormant, scattered throughout the spiral arms and the stars. Oh, the stars. We see Betelgeuse, a red supergiant so massive if placed at the Sun's position, its surface would extend past Jupiter. We see Polaris, we see Sirius, the brightest star in our sky. We see nebulae, clouds of gas where new stars are being born. Pink hydrogen glowing, blue young stars igniting. We see supernovas, explosions of white dwarfs stealing material from companion stars, until the pressure and temperature become so extreme, the entire star ignites in a thermonuclear reaction visible across billions of light years. We see pulsars, neutron stars spinning so fast they emit beams of radiation like cosmic lighthouses. Some spin 700 times per second. A teaspoon of neutron star material would weigh as much as Mount Everest. This is our galaxy, and it's beautiful, and it's just one. Zoom out again. Our Milky Way shrinks, becomes one spiral among billions. We enter the local group, 80 galaxies orbiting around a common center of gravity. Andromeda Galaxy is here. Larger than the Milky Way, 2.5 million light-years away. In 4.5 billion years, Andromeda and the Milky Way will collide. They'll merge into one superstructure. We call it Milkomeda. Stars won't actually collide. Space is mostly empty, but the gravity will tear both galaxies apart, reshape them, create new structures. Also in the local group are the Large and Small Magellanic Clouds, satellite galaxies orbiting the Milky Way, visible from the southern hemisphere as fuzzy clouds. Ancient sailors used them as navigation. Elliptical galaxies, lenticular galaxies, dwarf galaxies, each containing billions of stars. And yet, the local group is just one neighborhood in a vastly larger structure. Pull back further, much further. Now you see the cosmic web, galaxy clusters, superclusters, filaments of galaxies spanning billions of light years, connected by gravity, forming a structure like a spider web across the universe. Voids, vast empty spaces between filaments, completely empty, no galaxies, just darkness and a handful of atoms per cubic meter. The Virgo cluster contains 2,000 galaxies. The Coma cluster has 1,000. The Great Attractor, a gravitational anomaly that's pulling entire galaxy clusters toward it. We don't know what it is, we can't see it. We only know something massive is out there, attracting everything. Dark energy, 68% of the universe, pushing everything apart, accelerating the expansion. We know even less about this. Visible matter, only 5%. You and me, everything we can see. We're the minority in an ocean of unknown. Keep going, keep pulling back. The universe expands, galaxies recede, space itself stretches. Eventually, you reach a limit, the observable universe, 93 billion light years in diameter. Not because anything stops you, but because light from beyond this distance hasn't had time to reach us yet. The universe is 13.8 billion years old. Light can only travel 13.8 billion light years in that time. Beyond the observable universe, we don't know, maybe infinite universe. Maybe it wraps around itself. Maybe universes exist beyond. Maybe we're inside a simulation. At the edge, we see the cosmic microwave background. Radiation left over from the Big Bang, the oldest light in the universe, the farthest we can see. After this, everything is mystery. Here at the edge, looking back, you see everything. Every star, every galaxy, every supernova, every black hole. The entire history of the universe displayed before you. 13.8 billion years of cosmic evolution. You started on a rock, 12,742 kilometers wide, orbiting an average star in an ordinary galaxy in a quiet corner of the universe. But you're part of this. You're made of stardust. Iron in your blood came from supernovas. Carbon came from dying stars. Oxygen came from stellar furnaces. You're not separate from the universe. You're the universe experiencing itself. That's the journey, from Earth to the edge of everything we can possibly observe. A universe so vast, so ancient, so filled with wonders and mysteries that our minds struggle to comprehend it. If this journey amazed you, if you felt that cosmic perspective shift your understanding, please hit the like button and subscribe to the channel. We explore the cosmos every week. And here's my question for you. What aspect of the universe fascinates you most? Black holes, distant galaxies, the Big Bang, the possibility of other universes? Drop your answer in the comments. I read them all. Thanks for joining me on this cosmic journey. See you next time when we dive deeper into the mysteries of our universe.